The LDPC encoder is used for forward error correction through the use of low-density parity check codes. The LDPC encoder receives an information sequence of length k and generates a code word of length n, where n is larger than k. The unique aspect of the LDPC encoder is that the first n minus k bits of the code word are parity bits, while the last k bits correspond to the original information sequence. The encoding procedure uses a sparse parity check matrix H for code word generation. H is sparse, meaning that the matrix mostly contains elements of 0. Each code word is generated such that the matrix multiplication of the transpose of H and the code word sequence X equals 0. Displayed here are the LDPC encoder parameters. Automatic setup can be enabled to automatically set up the parity matrix by defining the maximum desired number of non-zero elements in the parity check matrix columns, using the parameter maximum desired WC. If the parameter automatic setup is disabled, the number of non-zero elements in the matrices columns and rows can be defined through the parameters WC and WR. The parameters k and n define the information sequence length and the code word length. The parameter parity only can be enabled to output only the parity bits generated by the encoder. By default, this is disabled, so that the LDPC outputs the entire code word. Once received, the LDPC code word can be decoded using the knowledge of the parity check matrix used by the LDPC encoder. The LDPC decoder uses the belief propagation algorithm under the assumption of a binary symmetric channel, which signifies that each bit has a probability of being incorrect. The belief propagation algorithm uses the log likelihood ratio as a decoding metric, and undergoes iterations until a valid code word has been found. Following decoding, the parity bits are discarded, and the LDPC decoder outputs the information bit sequence. The LDPC decoder parameters are nearly identical to the LDPC encoder parameters, other than the BSC error probability. This parameter defines the probability of receiving an incorrect bit, which affects the log likelihood ratio within the belief propagation algorithm. This example demonstrates the use of the LDPC encoder and the LDPC decoder. A bit sequence generator is used to output a predefined sequence of 8 bits, shown in the binary sequence visualizer. The bit sequence generator is connected to an LDPC encoder component and an LDPC decoder component, where the properties of the LDPC encoder can be seen on the right. Here, we will encode 8 information bits into a code word sequence of 16 bits. The parameter automatic setup is enabled, and the maximum desired number of bits in each column of the parity check matrix is set to 2. We can see in the parameters WC and WR that there are 2 bits in every column and 4 bits in every row of the parity matrix. If we examine the generated code word, we can see that the first 8 bits are the parity bits, while the last 8 bits correspond to the original code word. Following the LDPC decoder, we can see that the original information sequence was decoded.